All right, welcome everyone. Welcome to the 28th webinar in this discussion series on navigating tipping points, definitions and implications for climate science. My name is Elizabeth Kruger. I'm an assistant professor based at the University of Amsterdam. The goal of this discussion series is to acknowledge and advance knowledge on tipping elements, support efforts to increase consistency in the treatment of tipping elements in the scientific community, to develop a research agenda and design joint experiments and ideas for a tipping point modeling into comparison project, or TIPMIP. The networks behind the series are the Earth Commission and AIMS, the Analysis, Integration and Modeling of the Earth System Project. Both AIMS and the Earth Commission are hosted by Future Earth, as well as the Safe Landing Climate's Lighthouse activity of the World Climate Research Programme, WCRP. And this event is co-organized by the International Institute for Applied Systems Analysis, IASA, the Potsdam Institute for Climate Impact Research, and the Global Systems Institute at the University of Exeter. Before we begin, I would like to share with you some house rules. So if you have a question, just drop it in the Q&A box. Please make sure that you drop it in the Q&A box and not in the chat, because I'll only be monitoring the Q&A box for questions. The focus of today's webinar is on definitions and what a tipping point is. We have 3 speakers today who will present before the Q&A session. However, feel free to pose questions and indicate to whom your question is during their talks and using the Q&A feature at the bottom of the Zoom window. Everyone can upvote preferred questions so that those questions are more likely to get posed in the Q&A session. Following the event today, we will post the recording and the slides on the Tipping Point series webpage, so they will be accessible for everyone in the future. With those house rules and instructions, I would like to introduce our first speaker of the day, which is Vasilis Dakos. Vasilis is a senior researcher at the Institute of Evolutionary Sciences at the University of Montpellier and at CNRS, the French National Scientific Research Center. He's broadly interested in ecological stability, tipping points, and how co-evolutionary feedbacks may affect ecosystem resilience under global change. In particular, his research focuses on the emerging topic of indicators for resilience, or early warning signals for critical transitions in complex systems. Thank you very much for being here today, Vasilis, and the floor is yours. You can share your screen.
Thank you, Elizabeth. I'll try first to share my screen. It's always there it is. Do you see it?
Yes.
Okay, going to full screen. Now, full screen.
That works.
Can you all see my screen?
It looks good.
And you can hear me. Okay. Thank you very much once more. And thank you also the organizers for the invitation. I am, first of all, I have to say that I'm not a climate scientist. I'm an ecologist. But I have worked a lot with climatologists and climate scientists like you are. Also I have approached this issue of tipping points, of course, in ecological systems at different levels, population, community, mostly ecosystem level, having a bit of mostly of a theoretical perspective. And I think today I will be mostly sharing with you my view or my understanding on tipping points from this more formalized view, if I would say more conceptual and formalized view, and less from the empirical side that I also have some experience, but today I thought I would stick more to this more formal and conceptual side. So tipping points, definitely, you know, like oops. Should change my slide. Okay, maybe it's the connection. So tipping points definitely, a buzzword. I think at least once a year we get a big headline with the word tipping point. I like to read The Guardian, and this is my little collection of tipping point related titles, um, talking about either the climate emergency and climate tipping points, or tipping points at the ecosystem scale, in terms of the Amazon, or biodiversity issues like global biodiversity tipping points, and of course in more social related phenomena like the emergence or the spread of pandemics. And you see in all cases, I mean, you get this word of tipping point appearing and in the media, which of course it leads us to what we are discussing today. And I guess the need for discussing this today is because buzzwords have usually the tendency to become at some points misleading or confusing, depending on how we're using them. So what is a tipping point? Well, to answer this question, I thought to do a little journey by what I would do if I didn't know what is a tipping point. So first, I went to a dictionary and I looked at what the word is, how the word is defined, and it is defined as a point where a series of small changes or incidents could become significant enough to cause a larger, more important change. And that's quite interesting because I thought it's pretty, like not a bad definition, and it's actually resonates a lot with a book that has become quite famous related to the use of the term, where exactly you see the little print here is the whole idea behind this tipping point phenomenon is like little things can make a big difference, like small changes causing important change. So I thought, okay, that's not too bad for a definition, a generic definition like this. Then, I looked at Wikipedia, which is maybe, like a little bit more uses some expertise and some has this self-correcting process of better defining and describing things around us. And I found at least four listings for tipping points from in physics, in sociology, and in climate system. And which are all of them are basically like introducing the theme quite well, like a threshold with a sharp hysteresis loop. If you don't know what that is, don't worry, I will come into that later. An event when a previously rare phenomenon becomes rapidly and dramatically more common. Thresholds when exceeded can lead to large changes in the state of the system. So I thought, okay, that's also pretty in line with what I have in my mind. And then because, like now we're becoming, more and more into the artificial intelligence, I thought, okay, I will ask a GPT to define for me a tipping point. And I was actually, to be honest, I'm expecting that I would maybe get, like very confusing things, like of what a tipping point is, because I have also this intuitive feeling that maybe people are using them, like in different ways and not have clear definitions. And then what ChatGPT told me, he told me that a tipping point is in ecological and environmental science is a critical threshold at which a small change in external conditions leads to dramatic shift in the state or dynamics of the system. And when this is happening, then the system undergoes rapid or irreversible changes, leading to a new state. Then it gave me some examples. And then at the end, he told me some few characteristics, like, okay, you have this proportionality in the response, what he calls nonlinearity, have this threshold behavior. There's a point where something is abruptly changing. And then he introduced the notion of irreversibility. And to be honest, I was quite impressed because I thought, okay, if somebody ignorant about the tipping points would use that GPT would actually get, I would say, not a bad answer. And I also then asked ChatGPT what it would think if that is not a tipping point. So just like maybe sometimes by the opposite, by the opposite set, sometimes get to a better answer. And what I got is like, okay, that situation is not a tipping point when we talk about gradual and linear changes, where we have predictable responses to external inputs and not sudden or dramatic shifts. Again, it gave me some examples, and then it gave me a summary and a little conclusion, which I found very useful, telling me that, not all ecological changes. I don't know why it was, like it was drawing more intuition from ecology rather than, for instance, from climate science. But it told me that not all ecological changes involve tipping points, but some would involve steady, predictable, and irreversible changes, which I found that it's very healthy because we tend to, at least that's my, again, intuitive feeling, that we tend to perhaps overemphasize and overstress the existence or the emergence of tipping points when we see change around us. Of course, we're not the only ones who have been thinking about this. This is a paper back in 2016 in TREE, that's a Trends in Ecology and Ecology and Evolution related journal, where like a set of people among the author list is also Sebastian, who is speaking and is part of this event today. They tried to like to define and try to put already back then, like that's like 8 years ago, some clarity into the issue. And here they define the tipping point, or they kind of conclude to say that the tipping point is that situation where you have some accelerating type of change that will be caused by a positive feedback that will drive a given system to a new state. And this is the first time where, and here this definition will go away a little bit from how a tipping point looks like to what is causing it, that you have this ingredient, this mechanism of a positive feedback. And in a recent review on global tipping points, which perhaps, you could say it's for the moment the Bible of tipping points in climate, in ecology, in the environment, in social systems, like very comprehensive report drawing knowledge from very wide range of experts. Again, the way tipping point is defined, it involves this self-perpetuating before a threshold mechanism that would lead to big, widespread, abrupt, and irreversible impact. So actually, my conclusion after I was going through this little exercise was that I had the impression that tipping points are very well defined. So I was really kind of confused, or not confused, but like I was surprised. And then I thought, okay, why do we need to have this discussion? Because I mean, a very little search, I didn't have to go a long mile, and things were pretty well defined, and pretty well defined, at least from my perspective, because I'll give you now, okay, how I understand tipping points. And I don't know if you see all my screen because I have this little thing here, but there is this phenology related to the tipping points, like features, which is that tipping points should be situations where have some abrupt change, but abrupt relative to the driver, to the underlying conditions, and relatively to the time scale of our system. It should be unexpected in the sense that it will be caused by only small changes in the external conditions, not a big change causing big change. That would not qualify, in my view, as a tipping point. And it will lead to some very big differences, why usually they are related or called catastrophic. We are talking about, like moving from one place, from one state to a completely different state. Then the other element of tipping points has to do with the mechanism. Basically, to have the existence of a positive feedback, like for instance in the case of the coral reefs, where we have like two contrasting states: a coral state dominated by corals, and the alternative state, the contrasting state that is where the coral is dead and is outgrown by macroalgae, that's big plants living in the water. You see that in order to have this type of contrasting states and moving in a tipping way from one to the other, you have a strong positive feedback, which means that the coral has a positive effect on the herbivores, that's fish that are feeding on the macroalgae. They have a negative effect on the macroalgae, so they keep the macroalgae in low abundances, which leaves more space on the corals, as the macroalgae have a negative effect on the corals. So if you go through this loop, you get a positive outcome, which means that if you have more coral, you have more herbivores, you have less algae, so that means have more coral, and so on and so forth. So once you're reaching the tipping point, this type of positive feedback can propagate you from one situation to the other. And the last part that I find very important, which is related to tipping points, is that related, let's say, to their impact. It's not where what I mean with impact is like that under this situation of this type of positive feedbacks and this type of analogy, you get this situation where you will have irreversibility. Well, you will have, like situations where it will be very difficult perhaps to reverse that change. The change will be long lasting. And to visualize what I'm describing here, with the example of the corals and the macroalgae, what I mean is like we are not thinking on a situation where stress has a linear relationship with the state of your system, which means if you want to move, if that would be the relationship, to move corals into the macroalgae state, you need to have a very big change. And we're not thinking about big change, we're talking about tipping points. Also, one could think that maybe we're thinking for changes that are non-linear, but still they are gradual. That means that changing a little bits our environmental stressors, we have, like tiny steps until we reach the eventual, completely loss of the coral or of the coral cover. But what we are most interested in here is this situation where suddenly, the coral reaches a state, reaches a point, the tipping point that even a small, like incremental increase in the environmental stressor will lead to its collapse and the dominance of the alternative state. So it's this model that we have in mind, and this model, I have to say, that has been described very well in different situations in the physics and ecological literature, in the mathematical literature. There are different names that have been given to that. And now we have kind of, like substituted all these terms that are partly equivalent, but not exactly with this more generic umbrella term of tipping point. And as I said, like it has the characteristics that you have this abrupt, unexpected, and substantial change. You have this characteristic of the positive feedback that will propagate the change from this upper branch, from this healthy coral to the unhealthy coral dominated by macroalgae. And more importantly, we'll have this idea of reversibility. That means that, the full conceptual picture and mathematical picture is that if you reduce stress to a lower level, the system doesn't recover at the same level of stress at which it crashed, at which it first tipped. Instead, you need to reverse it to a much lower stress and reach another threshold in order to be able to recover the coral. And that's what is called hysteresis, the hysteresis loop. And that's what causes this concern of the potential irreversibility of the system, because perhaps we will not be able to reduce environmental stress in that such low level to have this reverse situation. So if I may conclude a little bit and give the space to my next colleagues, I would say, so is it a tipping point well defined? As I told you, well, surprisingly, yes, although it is a buzzword and I have the impression that it is used in mixed ways. If you look at there and you search for definitions in such simplistic way as I have done, you will find that definitions are way better summarizing what a tipping point is than I expected, at least. What though I think is perhaps less well defined and in the literature and overall is that element of the potential irreversibility, of the difficulty that the tipping point can be reversed if once it is crossed. Instead, I think there is more and more emphasis when we're thinking about tipping points in the phenology of the abruptness that is related to this catastrophism, that it's either we do it, like in our science or the way it's presented in the media. And I say this because to give you an example that is something that perhaps, like it says, misleading, because here I have a simple simulation where indeed there is a tipping point and there will be irreversibility, but we can imagine that there are two situations of the system where the system is changing very fast and the system where it's changing very slow. For instance, very slow, you can imagine the climate is changing slow, right? So you won't be able to see, like in our contemporary time, in our time scales, this abruptness, but still the system would have undergone a tipping point. Just to make the claim that the abruptness part is not necessarily the most important trait, but it's or feature of the tipping point, but it's more this irreversibility. And then if you ask me, okay, should we, like try to define it and, like keep on working on this definition? I would say, well, yes, I think it is important to keep on working on this definition or making although I think it is a clear definition by far, but emphasizing that definition because we just want to avoid misunderstanding. And and especially since, as I told you before, there's a whole family of related terms and also a whole family of terms that are related to tipping points themselves. Like here, for instance, I have noted things that, have become, another, like family of buzzwords related to tipping points, tipping elements, tipping dynamics, tipping events, tipping cascades, tipping systems. So if we're going to adopt this word and keep on using it, it's better to, like always make clear what we mean when we mean with that. And I think that's all I had to share with you today. Thank you very much.
Thank you very much, Vasilis. Maybe you can stop sharing the screen, and if anyone has questions, I saw a couple of hands go up. Please post your questions in the Q&A box, and we will address them at the end of after the last speaker. Now it's my pleasure to introduce our next speaker, who is Sebastian Battiani. He's a meteorologist and climate scientist by training. His research interests include tipping points and the interaction between the atmosphere and the Earth's surface, in particular concerning vegetation dynamics. Sebastian uses approaches informed by dynamical systems theories, time series analysis, and complex Earth system models. He also has a special passion for creative forms of science communication. Sebastian, the floor is yours. You may share your screen.
Yeah, hello. Thanks very much for the invitation. I'm sharing my slides now. So I hope this works. Okay. And yeah, I have a quite similar talk, similar to Vasilis' talk from the perspective of climate sciences, but I come to somewhat different conclusions, which I think is good for the debate. And I have to say that my talk is not a scientific results, right? So it's my perspective, my opinion about these debates about definitions. And yeah, like Vasilis too, we work together in a project called ClimTip about climate tipping points. There are other ongoing projects by the EU and others, and you mentioned already in the beginning this initiatives like TipMip, Tipping Points Intercomparison Project. There's a What If MIP. So there are a lot of activities ongoing about tipping points that even have tipping points in the title. And in the climate sciences, when I remember on previous projects, my impression was always that at some point in a project, at least one situation arises when people start discussing what do we mean with tipping point? And that leads to a lengthy discussion, typically, where people don't agree and don't come to a conclusion. And then it's postponed and it pops up in the next project. So that motivated me to offer my thoughts about this situation. And I would like to question if tipping points are really clearly defined. So I agree with the points that Vasilis showed. I will add a few nuances, how consistent that is between different studies or reports. So is this always consistent? And then do we actually need a specific definition among climate scientists specifically? And for what purpose do we need that definition in which kind of discussions? And then what should this definition include and what not? And finally, are we focusing on the wrong debate? So are these debates that I mentioned worth? And should we try to reach to a conclusion, or should we not aim for a common definition in climate research? Okay, so as Vasilis showed already, there was this famous book by Gladwell here, the same book, just in green. And this reminds us that the term tipping point originated in context of science communication about social sciences. And I think Bob will tell more about this. And there, the subtitle of this book, How Little Things Make a Big Difference, I think is very simple, and it gives a feeling, at least, what this refers to. Similarly, some more about climate sciences on the website of Carbon Brief. And they say tipping points are thresholds where a tiny change could push a system into a completely new state. So I think both are, of course, very vague, but they give a feeling, and people, I think, can connect to phenomena they know from everyday experience where something like this happens as well. And perhaps that's why in the media it has also become a popular term. And these are just 4 examples of media headlines in last years. And what I think is interesting, so I also, like Vasilis, I sometimes like to play this game to pretend that I don't know anything about tipping points or about climate change, or hardly anything. And then I look at these headlines and I think, okay, what impression would I get about the state of research? And for example, they say, okay, there are 5 tipping points, and there is 1 tipping point in the Amazon, and that may be reached, or in the ocean, it's heading for collapse, or here, the bottom right, we are halfway, and it sounds very precise, right? We're halfway to a tipping point with trigger, sounds a bit like a gun going off 6 feet of sea level rise. So altogether, to me, that makes the impression, so if I pretend to not know anything, that these tipping points are already well defined. I mean, they're not really defined in these articles, but somehow they hook on this this feeling that people have what it's about, and that we know already in which parts of the Earth system they are and where they are not, that we could count them in a meaningful way, and that we could measure how far we are from the tipping point and also can predict the consequences. So taking the hat of a researcher again, of course, that's not totally wrong, but there are also very large uncertainties. And I think that's not per se a problem for defining a tipping point, but it can become, the uncertainties can become a problem when we use a specific definition, because our uncertainty about the real world can mean that we don't always know which phenomenon, or about a certain phenomenon, if we should count it as a tipping point. And I will give an example in a minute. But so this is about science communication, but what about researchers themselves trying to define, and also to then define it in reports that are meant to inform also other researchers, but also the public or policymakers. So I looked up a few definitions in recent IPCC reports and other reports summarizing the state of knowledge. And interestingly, so the recent IPCC assessment report, AR6, has the most concise definition, where it says a tipping point is a critical threshold, then beyond which the system reorganizes. And so Vasilis also showed a similar definition. And it's a bit funny that it says then it may transition here and there and often abruptly and or irreversibly, but this doesn't seem to be a requirement because it's often, but not always. So essentially it's a threshold. And in the special report, 1.5 degree special report, it's a similar definition, but there is an additional criterion. When exceeded, can lead to a significant change in the state of the system. So that's something more that seems to relate to impacts. And the AR5, so the 5th IPCC report, even before that, and that had even additional criteria. I hope you see my mouse also. So I'm now on the top right. And okay, it's again, the system reorganizes, often abruptly, and does not return to the initial state if the drivers are abated. Not sure what they meant here. So for the climate system, more specifically, refers to a threshold when global regional climate changes from one stable state to another stable state. That's the examples Vasilis showed with alternative stable states, an example. So that's related to mechanisms. And the tipping point event may be irreversible, which makes me wonder, so if we have alternative states, why doesn't it have to be reversible? But okay, that's a mechanistic debate. But anyway, so this involves mechanisms. And again, here in recent science paper by Armstrong McKay, and also the global tipping report that Vasilis mentioned. So there is an additional mechanistic criterion that's not necessarily alternative state, but self-perpetuating. So there is some non-equilibrium effect that a system is not in equilibrium anymore. So on its own, without being further forced, it changes, still changes. And that is a similar criterion in a much older report about abrupt climate change. So the rate of the transition is determined by the climate system itself and faster than the course. So I think these are different definitions. So I would say it's not always clearly defined, or it's at least the definitions differ in the details, but they are always the same ingredients. So I really liked, Vasilis, I liked your expression of umbrella definition. And the differences come from, yeah, like adding or removing some specific elements, like how nonlinear, or this is typically at the heart of the definition. I would say that there's a nonlinear response to forcing. And then there can be hysteresis. That essentially means when we reduce the forcing again, we don't go back to the old state, irreversible. Then there are often ingredients related to mechanisms, as I mentioned, and also to impact sometimes. So yeah, overall, I'd say that we're running into problems because tipping point was not intended as a scientific term, but as a term to communicate to other parts of society. And luckily, the different ingredients are often relatively well defined in research. So I would say within research, maybe we do not need a precise definition of tipping point because we have all the tools to study nonlinearity or to study feedbacks and so on. And we may not need this umbrella term that defines everything. Of course, in the rest of the world, the term is out there. So in science communication, we need to address it. And so that's my opinion. I would say a working definition that we use in science communication, that should be simple. That's always nice. And it should not be too subjective. So not too much personal or subjective values. And it should not be too technical or involve mechanisms, because when we communicate to other parts of society, some stakeholders, I think it matters what is important to them. And that's often how the climate behaves and also the consequences, but maybe not so much why it behaves this way. So this is a phenomenological perspective, actually. So this is an example. It's the dependency of the area of Arctic winter sea ice. That's the blue dots here in a climate model. And this, when the global mean temperature gradually increases here on the horizontal axis, then we lose ice, and then there is this threshold where several million square kilometers of sea ice disappear within 2 or 3 years in this model. Yeah, and this was found maybe 2013 or a bit before even, that this happens, and we didn't know why. So it's just a nonlinear state shift when the external conditions vary. And then the other perspective, the mechanistic perspective, would be an example on the right side, dynamical systems. So that's what Vasilis already introduced. We have multiple stable states for an external condition. So for some external condition, we have alternative states, we have bifurcation points. This leads to hysteresis, irreversibility. And I would say if we make this a criterion, and in the case on the left side, it turned out later that you do not need positive feedbacks to explain this phenomenon. So it's a reversible threshold phenomenon. But that would mean that suddenly, so we research this case and suddenly we learn more about it, and suddenly it's not a tipping point anymore. And I think that's maybe a bit awkward, and maybe the mechanism doesn't really matter so much when we communicate the results. Okay, so to wrap that up, I would argue that as a scientific community, maybe we don't need to try too hard to define tipping points clearly in scientific projects or in communication with other scientists. So to make progress in science, we don't need to define it. It sounds a bit contradictory, but we have all the tools. For example, we can ask how sensitive is Arctic winter sea ice to forcing and so on. So we don't need to define tipping point, but when we communicate the results, this is a good label how to frame the results, right? So we should address that and define it in conversations. And as I argued, I think in this context, it makes sense to focus on the phenomenon, what happens if, but maybe not rely too much on mechanisms in the definition. Okay, thanks very much. And of course, I'm interested in your opinions.
Thank you very much, Sebastian. I already have so many questions to both you and Vasilis, so thank you very much for the contributions. But a reminder, I don't see questions in the Q&A yet, so please make sure you post them in there to also give people a chance to vote them up. While you do that, I will introduce to you our third speaker, which is Robert Kopp. Bob is a climate scientist who serves at Rutgers University as a distinguished professor in the Department of Earth and Planetary Sciences. He directs the Megalopolitan Coastal Transformation Hub, a National Science Foundation-funded consortium that advances coastal climate adaptation and the scientific understanding of natural and human coastal climate dynamics. He is also a founding principal investigator of the Climate Impact Hub, a multi-institutional collaboration advancing data-driven approaches to estimating the social and human costs of climate change. Professor Kopp's research focuses on past and future sea level change, the interactions between physical climate change and the economy, the use of climate risk information to inform decision-making, and the role of higher education in supporting societal climate risk management. And with that, the floor is yours. Bob, you may share your screen.
Thank you, Elizabeth. So this will be an interesting conversation. Thank you for inviting a set of speakers with a very diverse set of opinions. I agree with much of what the past speakers have said, but take it in different directions, particularly from Vasily, but also somewhat from Sebastian. So I'm going to take as my question, not the question, can climate tipping points be defined, but whether they can be usefully defined. And I'm going to get to what I mean by that in a second, but I wanted to acknowledge that this is a conversation. You know, I first published on tipping points in 2016, so this has been in my mind for a while, but really with a number of colleagues, I've been having a pretty critical conversation over the last year and a half. Particularly Liz Gilmore, Rachel Schwam, and the others whose names you can see listed there. But I am responsible for all of my mistakes that I'm about to make. So I want to start by presenting my theses, and then I will present the argument for them. So I have sort of 5 key points I want to make. So first, what I'm going to call the tipping points framing has spread contagiously, and I don't mean that as an insult. I mean it as a tribute to the origin of the term with Malcolm Gladwell over the last 2 decades. And its actual use is not going to be shoved into a nice technical box, so we might try. And I'm also going to argue that it never actually was in that technical box. And even things we think of as core examples are not etymologically consistent with the use of the term point in the name. So I will argue, I think like Sebastian, that the term is best viewed as an imprecise, boundary-spanning term and metaphor, and you can think of terms such as sustainability or resilience, which I think most people would agree have meaning in specific contexts, but not a single meaning that spans all their context. And so as such, I think the key question is not how to define tipping points, but whether in what context the term is useful, and I mean useful either for communication or for knowledge accumulation, right? Is there something to be gained by taking all of these things, which in general do have these sort of common properties of involving complex systems that have feedbacks, but that is also something that most of the universe has, and trying to view them collectively. And I'm going to argue that this key question ought to be informed by social science research, not as I think it largely has been by the intuition of physical scientists. And I'm also going to argue that I think I see some dangers in the way the term is being interpreted broadly and the confusion it's causing. And so therefore our default position ought to be one of skepticism. And I'm going to argue for alternative, more precise framings, but perhaps one's a little more interpretable to the general public than things like bifurcations. So for instance, potential surprises that are unknown likelihood but high impact, and that we should think about whether some of these more specific terms should be more adopted both for scientific use and for communication. So let's talk about the history of the term. So the first academic use of the term comes from theories that I think are fair to say are generally debunked at this point about racial segregation in the United States. So there's Morton Grodson's writing in 1957 in Scientific American. As Negroes move in from the South and whites move out to the suburbs, a new pattern of segregation emerges, bringing with it significant economic, social, and political problems. And there's already popular use of the term has sort of a colloquial before Grodson's use. Real estate operators seeking higher revenue that comes with Negro overcrowding talk freely among themselves about tipping a building or tipping a neighborhood. So that's the early history. This chart here is from Google Ngrams. For those of you who aren't familiar with it, this is showing the frequency of the occurrence of a term in the corpus of English language work. So this green term is the frequency of the term tipping points, and I'll zoom in on the bottom to look at climate tipping point and social tipping points in a second. So 1996 was when Malcolm Gladwell published his New Yorker article on tipping points. 2000 was when his book that we've already talked about came out, and you can see he really catalyzed or at least captured a pretty severe and perhaps tipping uptake, contagious uptake on the term. Now, Malcolm Gladwell, as you ask where he came to this term, said in an interview on Gladwell.com, it's the name given to that moment in an epidemic when a virus reached critical mass. It's the boiling point. It's a moment on the graph when the lines start to shoot upward. When I heard that phrase, I first remember thinking, wow, what if everything has a tipping point? Wouldn't it be cool to try and look for tipping points in business or in social policy or in advertising or in any number of other non-medical areas? So this is climate tipping points come after this. So this is the important thinking of the intellectual milieu that our work in. So now let's zoom in on the blue and red curves here. So the blue curve is the frequency in the corpus of the term climate tipping point. The red term is social tipping point. So the first, at least documented usage of climate tipping point that we could find comes from Jim Hansen in a Schneider lecture at AGU in 2005. But it's clearly in the ferment at this point. Gabriel Walker in a news article in Nature writes that at 2006, the idea that passing some hidden threshold will drastically worsen man-made climate change has been around for decades. Now it has gained new prominence under a new name. In 2004, 45 newspaper articles mentioned a tipping point in connection with climate. In the first 5 months of 2006, 234 such articles were published. The idea is spreading like a contagion, again, referencing back Gladwell's linkage of tipping points and contagion. Of course, the seminal work in this area is that of Tim Linton and colleagues in 2008. They really captured, and were contributing to this uptake here. I'm sure some interesting science studies person will tell us about the leveling off between 2010 and 2015. I have no ideas what happened there. And then it's really sort of continued to grow quite quickly since then. So first, I just want to, I think we need to be skeptical just even in core cases about whether we have chosen misleading etymology. So I would argue that if you call something a point, it ought to have 0 dimension. Otherwise, you have no business calling something a point. And so the question is it fair to call something a tipping point if there is no point that can, even in theory, be identified prospectively? That is, it's fine to say if there's a threshold and we don't know where it is, that's fine. There are lots of things we don't know. But if that threshold actually would not be at the same value every time you replayed the history of the world, I don't think it's accurate to call it a point. There might be a zone of increased risk of tipping, but there's no point. And has a proof of concept here. This is from a study from our colleagues at the Goddard Institute for Space Studies. So using the Model E global climate model. So they ran SSP 245 out to 2400, a 10-member ensemble. This is the strength of AMOC at 48 degrees north. So one of these classic tipping points. Identical forcing, right? So this is the CO2 forcing curve here. 8 out of 10 ensemble members experience a reversible decline in AMOC. 2 out of 10 with the same identical forcing experience a collapse. And so therefore, retrospectively, one might, if you're in one of these two worlds, identify a tipping point, but there was no tipping point in warming levels that would have been consistent across states of the world. So I'm going to argue if you use the word point, that's okay if you have epistemic uncertainty, meaning you don't know where it is, but it's really not linguistically honest if you have aleatoric uncertainty, right? There is no point if you replay history with identical forcing and it doesn't yield identical results each time. Now, one might say, well, maybe there is a point in the internal dynamics of the system that should at least scare us off of referencing tipping points to warming levels. So then let's look at some categories of things that are put under the labels of tipping points. So do Earth system tipping points have much in common with one another from a practical perspective? Yes, I agree they all involve feedbacks, but again, the world is a complex system. Most things involve feedbacks. What do we necessarily learn from grouping them together? So coral reef die-off, based on the Armstrong-McKay survey, there's high confidence that this is something that will happen between 1 to 2 degrees C, but it is also clearly globally diachronous. There is not a global tipping point warming level beyond which all coral reefs instantly die off, and it is strongly affected by non-thermal factors like light, calcite, oxygen, human stressors, adaptation. The West Antarctic ice sheet collapse, on the other hand, there is deep uncertainty in warming threshold, so unknown likelihood, high impacts. And there's also centuries to millennial lag between when we experience the sea level commitment, which is costing the tipping point, and realization, which I think is a very important distinction for at least popular understanding of the term. Because certainly in the origins of the use of the term tipping point and in the public understanding, it is abrupt, not just in some theoretical sense, but in some actual sense that makes sense to normal humans. Okay, so what are other things that are put under this umbrella? Negative social tipping points. Do Earth system tipping points and negative social tipping points have much in common? So on the left, we've got a photo from West Antarctica. On the right, an illustration of the negative social tipping points of anomie, which is a sociological term for loss of social norms, polarization, and radicalization. Do we actually gain anything in terms of understanding by trying to understand these as representatives of the same dynamics? I think we have to ask ourselves that seriously. I mean, one might say that, well, perhaps climate tipping points makes negative social tipping points more likely. I would buy that, but also lots of other things make negative social tipping points more likely. I think it's certainly questionable is whether there's a reason to think large-scale Earth system phenomena are more likely to cause polarization and radicalization than many other phenomena we see happening already. And in fact, we argued in our 2016 review that in thinking about negative social tipping points and their triggers, probably one ought to give a lot more thoughts to things like compound extremes and more extensive and frequent extreme events that are high likelihood in general, although maybe individual events are low likelihood, but that we know we're going to are seeing a lot more of, and how those pressures could contribute to social tipping points as opposed to climate tipping points. And what about positive social tipping points? Technology learning curves, for instance, driving the transition to clean energy versus a collapse of the West Antarctic ice sheet. Again, yes, one can mathematically draw commonalities before them, but what does one gain really by trying to put these in a common intellectual framework? And then here's another use in the literature, we can't just dismiss it, adaptation tipping points, which are actually just risk management thresholds, have nothing to do with feedbacks, could be caused by the latter, right? If they have an adaptation tipping points in terms of how much sea level your seawall can experience before it ceases to be useful, but it really has nothing dynamically in common with these other examples. So if there are such a broad set of things that fall under the category, why are we using the term? Well, I think the early authors on this were quite explicit. So Linton et al. 2008 justified their review of tipping points because of increasing political demand to define and justify binding temperature targets, as well as wider social interest in nonlinear climate changes. And Linton and Schellenhuber, as well as other writers of the same time, drew explicit linkages between the idea of inducing a positive socioeconomic tipping and as a way of avoiding climate change tipping points. So in short, we are using the term because of the policy goals of the climate scientists who first adopted the term. And one might question whether that's an appropriate way of defining terms, but I agree with those policy goals, so I'm not going to contest that, combined with their intuition about effective communication, right? So if you're going to do something because you think it will focus people's attention, I would argue one should ask whether there's evidence that it'll achieve those ends. So is this frame likely to be effective with respect to policy goals? Well, I think this is a useful area for research. Where Rachel Schwamm and I did a review article about 5 years ago on looking at social science theories explaining when societies act before a crisis and explaining them not to tipping points in particular, but just to climate change in general. And I'm going to show a few of these to you here, which at least should give us some skepticism about whether tipping points are well suited for inspiring action. So looking at sort of individual risk perceptions, construal level theory says that action on a long-term risk is more likely when people perceive the risk as happening sooner rather than later, when they perceive it as happening in areas geographically local, and then they perceive it as happening with high certainty. And these are all traits that are the opposite of what most climate tipping points happen. Climate tipping points are generally perceived as happening in the future, as happening at a distant or broad global scale, and certainly having deep uncertainty. So they're not, from a psychological perspective, well aligned to inspire action. And then from an institutional perspective, well, risk society theory says that action is more likely when assessments of risk and damage are estimated quantitatively and with certainty. Again, the opposite of tipping points. And perhaps, in my mind, the most important, the focusing event theory says that action is most likely when you have a policy community with long-term solutions in place for a policy opening. So maybe we could do that. But then there is a clearly identifiable focusing event. Say, think about in New Jersey in terms of a sea level adaptation, it was Hurricane Sandy, an obvious, visible, immediate event that draws attention and creates that policy opening. And the nature of most tipping points is such that they are going to be hard to identify at the moment they are happening, certainly in any salient way. There's not going to be a single day the West Antarctic ice sheet collapses, and that convinces everybody we need to focus on sea level rise adaptation. So again, I would say I think this is an area where there's not research looking quite specifically at the question of whether tipping points are effective in response to policy goals. But there is a number of social science theories that would lead us to perhaps a default hypothesis that probably not. So then I want to also raise quite the communicative effects of using this terminology be harmful. And I am concerned because you do see a number, and quite frequently, people confusing temperature thresholds with tipping points. The United Nations talking about reaching the critical 1.5 degree tipping point by 2035. The National Resources Defense Council talking about once past the 1.5 degree tipping point would precipitate a cascade of devastating effects. The Central Bank of Malaysia talking about a 1.5 degree tipping point beyond which the damage to our environment would be irreversible. Well, here we see clearly confusing a policy threshold with the traits that we have said are often associated with climate tipping points. And I think if we don't help people understand that 1.5 degrees C is a policy target, not a tipping point, it risks a number of things. One, it risks fatalism. Well, we are going to overshoot 1.5 degrees C. Therefore, we're committed to these irreversible harms. And so maybe we should just give up. It could risk justification of potentially harmful emergency interventions. Well, it looks right now we're going to blow through 1.5 degrees by 2035. If it's really this catastrophic tipping point, maybe we flood the atmosphere with sulfate aerosols now so avoid it. Or perhaps most likely, if everybody thinks the science is saying that 1.5 degrees C is a critical climate tipping point, when 1.55 degrees C looks like a marginally worse 1.45 degrees C, that rests credibility, threatens the credibility of the science. Now, I would say, I critiqued the intuition of physical scientists as a basis for choosing the tipping point framing. These are my intuitions and my hypotheses, and I think they should be critically studied. But I think there is at least reason for concern when you see prominent organizations and lots of other people confusing two very different things of a policy target and some property of a physical system. And so I want to conclude by arguing for intelligible framing devices, but ones that are more specific to the characteristics that we think are actually of concern. So I see Michael Oppenheimer in the audience. I heard him do a New York Times event a couple of weeks ago with Stefan Rahmstorf, and Stefan, when he was saying, well, why should we care about tipping points? What he actually said was, well, because we don't know how likely they are and they could have substantial impacts. And I agree, we should study things that we don't know how likely they are, that we don't know how to model very well and could have substantial impacts. But there's nothing in that that requires those to be framed as tipping points. They are potential surprises that could be devastating. Or in more technical terms, they are unknown likelihood, high impact outcomes. You don't need the tipping points metaphor for that. And in fact, in the sea level world, which is one place where we actually see high-end sea level rise driven by what someone called ice sheet tipping points incorporated into adaptation planning, the tipping points is really tangential to it, right? It's a high-end, it's these low confidence, unknown likelihood, high impact sea level rise projections out there. And I should also add, I think AR6, we screwed up a little with the terminology. In the sea level chapter, we just talked about high-end sea level rise. In the SPM, the phrase low likelihood, high impact was loaded with two meanings. One is actual low likelihood and high impact, but the other was unknown likelihood, as in the case of deep uncertainty. And I think those are two very different things. Most of the Earth system tipping points, like all of this red from David's paper, that's low confidence. There's a lot of low confidence, so therefore unknown likelihoods in this system. And there are certain situations in low likelihood to high impact is important to study, but there are also a lot of situations in the fact that something might be high likelihood, we just don't know, makes it even more important to study. And I think we need to, I would argue that potential surprises of unknown likelihood and high impact is actually why most of this research on tipping points ought to be done. So thanks.
Thank you very much, Bob. I really like the different angles from which the three of you have been speaking, or particularly Bob in comparison to Vasilis and Sebastian. So three excellent talks, and I think, we can move into the discussion session. I invite everybody again to pose their questions in the Q&A session. And I would also like to invite Vasilis and Sebastian to respond to Bob or to comment on each other's talks. But perhaps to sort of add another thought in this discussion, because my impression is that Sebastian and Vasilis are, or maybe everybody is quite comfortable saying, okay, I think I know what a tipping point is. The definition is clear. Clearly, they are very uncertain. So the problem lies more in the communication than in the definition itself. And please respond to that if you don't agree. But I actually also attended another event with Michael Oppenheimer, not the same one that you attended, Bob, but I raised a point that triggered me during his talk. And that is that in the whole discussion about high uncertainty events, we've been at a point in the past where we were discussing the risk of flood events in the form of return periods of floods, like a 1 in 100-year event or a 1 in 1,000 years event. And these events, if they occurred twice within a 20-year time span, people said, oh, what is this? It's supposed to happen only once in 100 years. So in a sense, as scientists, we're not very good at communicating uncertainties. And so maybe this is a similar situation where we are sort of forced to give a simple concept, a simple answer to a very complex phenomenon. And even the 1 in 100-year event, it was expressed as a probability with high uncertainty, which is what you're proposing now, Bob, for communication. I wonder whether it has the effects that we want to achieve in terms of urgent climate action, behavioral changes, etc. Yeah, what's your response to that?
So two things. So one, this goes back to my focusing event theory. Or not my focusing event theory. I can't claim credit for it. Goes back to what I was saying about focusing events, right? And according to this political science around focusing events, right? Typically what happens is that you have a focusing event and then that spurs action. We have lots of focusing events. Open the newspaper. Right? In the US in the last 2 weeks, we've had 2 devastating hurricanes striking the Southeast. So I don't actually think it is a lack of focusing events as a spur to action. So if there is something, so I would say from the utility there of tipping point from a policy perspective, yes, clearly you go back to some of what Tim and Jim Linton and Jim Hansen were doing in the 2000s. There was a reasonable hypothesis at the time, well, people weren't acting enough. It was because they weren't paying attention to these high-end risks. But look, we don't need to draw more attention to climate risk just to trigger actions. I think we have, at this point, we have to ask, well, what meaningfully different do you do because of this nature than because of the fact that we are already experiencing excessive, extreme, dangerous climate change? And does adding abstract, distant climate tipping points to the discourse actually change the policy discussion? So that's one thing. I mean, and so his question is, well, okay, we're now at a time when the question is not, do you act on climate or do you not? It's what specifically do you do? And are there meaningful policy channels whereby tipping points would lead to different policy recommendations than, like, we're experiencing hundreds of billions of dollars from climate intensified extreme events every year, and people are dying. And so I think like I think why we tipping points in particular is because these are unknown likelihood things, so they could happen. We just don't know yet how to assess them, and they could have significant consequences different from whacking all the world with extreme events at high frequency. So we do need to understand that, but it just, like, I don't love temperature threshold targets either. Like, they think they're fine, but I think that well, we're already experiencing dangerous harms from climate change. There's already too much carbon dioxide in the atmosphere. I think people increasingly recognize that. So then the question is, well, what then? That's
Well, to that point, and also to respond to some chat comments going around. The problem with that is, did we already have enough triggering event 20 years ago when climate action was urgently necessary? And now the uncertainty around climate tipping points is so high that we might actually have committed emissions already so deep in the system that we have already passed the tipping point. So that's just as a...
It makes me really anxious when anybody says the tipping point, right? Which is really the temperature threshold tipping point, right? I mean, like, to the extent that there's value in this, there are lots of different things in the Earth system and lots of different tipping points, right? And so context of a singular tipping point elevates all of my concerns even more.
Okay, I'm going to go to the questions raised in the Q&A. We have a question from Shreyas Gadge, who says, thank you very much for your talk, Sebastian. I was wondering if a phenomenological definition for every system would lead to more division between fields into understanding of the concept itself. I understand that a dynamical systems perspective comes mainly from physics, but do you think that it helps more with a shared understanding across interdisciplinary scientists? So don't we need to define what we mean by tipping points in order to ensure that we can work across disciplines, if I understand that question correctly?
Yeah, of course, I can't speak much about other disciplines where I'm not an expert, but I think it rather helps if we don't have too many mechanistic restrictions in the definition. So that was my point that I tried to make at the end. So if it's more like, so in a way, small things make a big difference, right? So that was successful to communicate such nonlinear behavior, and that can happen in many disciplines. You just relabel the axis essentially. So I don't see a problem in that sense.
Okay,
Yeah.
thank you very much. And I have a comment. Yes.
I just want, so I think we also have to be cautious of physics imperialism for another reason, which is, right, in social systems are complex systems with agents who have autonomies and values, and just porting a physical dynamic system over to social systems basically strips out the autonomy of those individuals. So I think you got to be super conscious of that. And the people who work on positive social tipping points are aware of this, and many of them argue for talking about tipping dynamics rather than tipping points, partially for that reason. But I think we do have to be aware that humans are autonomous agents with values, and so you can't just take a physical dynamic system and apply it to humans.
Which would imply that we need to be careful whether we are talking about physical tipping points or social tipping points.
So can I say something on that? Because it's not only social systems that are complex. I mean, work on ecological systems and in theory they are, or maybe somebody would expect it simpler than social systems, and that we know a lot and we still fail. But I don't think the fact that we don't understand them and they are complex should limit us from trying to approach them from the perspective of tipping points or some, like mathematical or physics inspired, literature or approach. Because I think if I may make a comment now, I take an opportunity to what Bob was presenting. I think, both Bob and Sebastian to some extent, they were, presenting, at least for me, that how I see it, like, okay, not whether necessarily, like tipping points can be defined or is there a definition, but whether how they are defined in practice. Is it how they're applied, basically, like, are they applied in the right way? And this reminds me, because it's similar history, 73, 74, Zeeman used this model from René Thom of this shape that we have been presenting with the catastrophic bifurcations, and he came across with the catastrophe theory, and there was like a kind of again, the same approach, tried to force this type of system in everything around, which intellectually it's super interesting. I mean, I think that's why we're doing it, because imagine that, like the law of math, comes across all disciplines. And I think that's the motivation. But then, of course, you always need to, question, okay, can you really, fit that curve? Can you really say that that is a tipping point? And then I completely agree with both speakers that the way it is applied, that's why I said for me it was surprising that the definition was very clear. But then the way it is applied, even from within, from the scientist perspective, not how it's used in the media, there you see, I can see it also in my work, because I also work with this, and resilience. You think it's not well understood, it's not well applied, and that's what I think creates the problem, and to some extent at least discredits the idea. And then people think, oh, like it's tipping points, what's the point? Like, so I completely agree with this, but I think it's a different question, like whether do we have the theory, do we know enough from the theory, from the concept, blah, 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 do we have good definitions? I would say relatively yes. I was surprised to see that, like, as an ignorant, just Googling, I would find more or less the proper ideas. But if it's really well done, well applied, I would say no. And I think then that's for me at least, that's one distinction.
So, sorry, so I totally agree. I think the analogy to catastrophe theory is a good one. The one thing that I think is extra incumbent on tipping points, and get, maybe this is true a little bit to catastrophe, but it's very clearly true for tipping points, is that this started as a buzzword. It started as a communication strategy, and then had the technical bit grafted onto it, right? It was not, when the early climate tipping points people worked on, they weren't going back to Grosland and Schelling. They were going back to Malcolm Gladwell, right? And so, so I think it is therefore for tipping points in particular, I don't think it's a necessarily that helpful a discussion to have, well, can we technically define this in a frame and ignore the communications effect? Because it wasn't created that way. It was created by building off of a buzzword. And so I think that the sort of, well, thinking of it as a communication problem, it is inseparable from how we continue to use the term.
Just a little respond on that. At least from ecology has been using the word regime shift a lot, and then was using the word catastrophic shift. So really nailing it to catastrophe theory and catastrophe bifurcation. Tipping point was something that we borrowed from I mean, we borrowed. Maybe I'm wrong, but I have the impression that it came through climate science, but it came to kind of, like, play the trend from a concept that was not in Gladwell's ideas. There was already, like, Zeeman and more mathematical inspired ideas. But this perspective with the that you say with the media, yeah, and communication, to be honest, is something that I never really thought. So it's a very interesting, perspective.
I'm going to throw in a few comments / questions from the Q&A, which also fall into this topic. So Kai Greenlees says, from my experience with climate activists, climate organizations have found climate tipping points very helpful to communicate the existential risk of the climate crisis to urge action. So as a communication tool, it seems it's already being actively applied in useful ways, more so than high impact, low probability speech. Maybe our role as engaged academics could be to move to connect what activists are picking up and translate that to policy or industry spaces. I would be interested in the panel's experience with tipping points as a communication tool to different audiences and what you saw as strengths / weaknesses. This is followed by Steve Smith. Have you asked, a question for Bob, have you asked many political and business leaders whether they find tipping points a useful term? Have you asked them whether they'd prefer to motivate action and policy agenda setting by talking about how we avoid unknown likelihood, high-level impact dynamics? ? And then Keith Alverson says, Yes, Googling, you can find the right ideas, but you can also find massively incorrect statements, such as the UN stating the 1.45 global average temperature as a tipping point. Those three things, and I'll let maybe Sebastian also respond to give him a chance to say something. And I also see one raised hand. Nico Wunderling, if you want to type your question in the chat, that might be easier. If there's time at the end, I'll give you the word. Sebastian, your response.
Yeah, okay, thanks. Great debate. My impression is, I think it's not just so using tipping point in communication. It's not only the purpose to try to convince people to stop climate change, for example. And in general, I mean, there are like semi-entertaining educative formats where, for example, science slams, where people are also interested to learn something about the world. It's not automatically about what should we do, but it's also they want to understand a bit more how the climate behaves. And then I think it's really valuable to connect. So as I mentioned, to everyday experiences or come up with examples of things that suddenly break down or so. And then I think tipping point can be a useful term, right? So I think even if we sort of connects a bit to what Bob said toward the end of his talk, yeah, I think even if we knew nothing would change about climate policy or climate action, it could still be useful to explain it's not just a gradual change and things get worse, but there can be sudden changes or nonlinear changes. And I think also when we discover that this is possible or plausible, we should tell people, right? So that's part of an educative, let's say, or communicative purpose. So I think that it has a purpose.
So, okay. So for a couple. So first of all, I was not suggesting unknown likelihood, high impact for public communication. I was giving it an example as traits. So this is responding to the comment, not to you, Sebastian. Potential surprises is what I would suggest as the category for public communication that corresponds to that. That's what you used in the 4th U.S. National Climate Assessment. But there are also abrupt changes, irreversible changes. Once if we could promise not to try to put a particular technical frame on it, I might even be okay with tipping points if we did the research to show it doesn't cause fatalism or loss of confidence. It doesn't risk these concerns I've raised. But I do think there's a concern. Look, if we're viewing it as a communication challenge, we need the experts, and we are not the experts. We're climate scientists or ecologists. So I think that's the first order thing, and I do see enough misinterpretation of it that I am concerned at the moment. And to Steve Smith's question, I haven't talked to necessarily political leaders, but I have talked to quite a few diplomats and sort of mid-level civil servants who are quite concerned about what they see as this being sort of picked up. Because again, there are a lot of things with high confidence that we are not dealing with. And many of the things we need to deal with the potential surprises are also the things we need to deal with the high confidence risks. So, right, it is useful, and we do this in the sea level space with mixed success to say, okay, are we making decisions now that will come back and bite us if we are in one of these high end scenarios? Avoid doing that. But again, the only example I can think of tipping points, broadly speaking, being used to inform adaptation is with the case of high-end sea level rise, and tipping points really are not, sometimes they're used for explaining it, but they're really not core to thinking about West Antarctic ice sheet or Greenland ice sheet collapse and its potential contribution to driving multi-meter sea level rise. That's just in practice, it's irrelevant whether those are tipping points or just things that we don't know the likelihood of, but might happen. Yeah.
Okay, thank you, Bob. Vasilis or Sebastian, would you like to respond to that? Because in the chat, I have more questions for Bob, so I also want to give you the floor if you want to respond.
I think we can go on. Maybe just, one point, little point that Keith raised here, as far as I understand correctly. So of course, there are all kinds of wrong statements out there. So I agree in this sense that it's not automatically maybe a flaw in the term tipping point if somewhere it's stated that 1.5 degree is a tipping point. Of course, that's wrong, but I mean, wrong statements are everywhere. So as I think as was mentioned before, it matters more how we make clear what we mean with tipping point, and that this cannot happen. And sometimes I have the impression it is misused. It's to cause some interest or excitement, right? So people accept that there's this misunderstanding. So I think we shouldn't let that happen, because that undermines the trust in science.
But Sebastian, if I may add to that, I think that's true with almost everything that is partly controversial. So, so Bob, sorry, but if we call it potential surprises, they will not use it in the similar way.
Well, but
they will not make false statements. They will not say it's going to be a big surprise. We can call it potential tipping points. Like, as we said before, people don't understand, even ourselves, we don't understand uncertainty. We don't understand discount, the future, you discount it. That's like classical, like people, at least when we talk about action and motivating people or like this. I think if there is an opportunity, any term you put, it will be misused.
So I don't disagree, but tipping point is being actively misused now in a way that I think, at least there's reasonable to think could, as Sebastian and said, have him pick us back on credit in terms of credibility fairly soon, because we are going to pass the 1.5 degrees C so-called tipping point, and it's not going to be a cliff. And so if people think that was why we were focused on 1.5 degrees C, then there are going to be people who try to use that. I mean, look, there are lots of attacks on the credibility of the science all the time. We don't need to be doing things that lays the groundwork for more attacks on the science. Now, again, hypotheses, we need people studying it. I wouldn't have guessed a month ago that there would be a significant chunk of people in the US who think that Jews are controlling hurricanes with space lasers, but we do seem to have some prominent politicians who think that's the case. So maybe this is all up here and we're all the way down here, and it's completely irrelevant.
I completely agree that like misuses, like also contributing to the misuse, because we don't think so much about the word, or because we don't apply it as well, or because maybe we want to say, to make a better, to find something more than what we actually find in our results. I can see that responsibility, but I don't know how. I think it's one point is inevitable, but I don't understand necessarily how by changing a word, we will treat that, or who is going to be like policing this the way
in that
users
sense,
are applying. The only thing that you do, you assume that, and I think it's happening, that like the next model comes and refutes the the previous let's say finding. Oh, they claim this, but we find evidence that it's not the case, and that's how science progresses, right? Of course, I have a naive understanding and perception of that, but I can see our responsibility in that part, because I don't have so much experience in that, the bridge to the communication. I don't know how else can I go out and like police and say this is not correct, or use it correctly, or you see, like, which I don't think necessarily is going to be by changing the term.
So
I don't think we're going to resolve this today, and
Probably not.
unfortunately we have to wrap up.
But it's good to think about these things. I think Bob brings it very
Yeah.
for me. I find it very inspiring, because I never thought that me choosing the word, even I choose it correctly, I maybe contribute you know, like in the negative use of that, although I think I'm using it in the right way.
Maybe we should have a session about the use of the term tipping points rather than the definitions. I'm going to read out one last comment from the Q&A, and then we'll have to wrap up. David Armstrong McKee says, thanks for the nice talk, Bob. In one of your points, you frame tipping points as a transdisciplinary boundary object like sustainability and resilience, and then discuss why it may not be instrumentally useful in the context of policy and action. But do you think it has been useful to some extent for generating knowledge within natural sciences by acting as a novel scientific construct, focusing attention on a previously underappreciated set of natural phenomena? I do think that tipping points tend to be overly reified, even in context, though, rather than treated as a useful construct model for understanding a complex reality.
So,
I'll give you half a minute to respond, and then we need.
So I think most of the things that are labeled as tipping points are interesting to study and potentially impactful. But I also think, they largely fall in the category of things that might be potentially impactful, but we don't know how to model very well, which I would call potential surprises, and therefore we ought to study them for that reason. So in the counter history where back in the 2000s, we said, okay, shoot, there are all of these important, impactful phenomena that are not in our models that we need to better understand. Could that as also, been useful as for generating knowledge within the natural sciences? We don't need to run the clock back on that. But I do think there are lots of interesting things under the label of tipping points. And the question is just simply, are they being framed in a way that is having, that is forcing us to look for commonalities among them that are not necessarily critical to their study, and that also are having sort of malcommunicative effects.
Okay, thank you very much. I'm afraid we have to close. I don't know if we have the possibility of staying on for those who want to continue debating. But anyway, I want to give a round of applause and thank you to our speakers again for the excellent presentations and for taking our questions. Many thanks to all. For those of you who are still online and who participated. Our next event will take place on November 5th and will focus on uncertainties. Please register through the link that was posted in the chat earlier on by Caroline. New events for 2025 will be announced on the website soon. Also see the link in the chat. Thank you very much. If anyone has final comments, I think we can stay online for 1 or 2 minutes if you wish to. Vasilis, Sebastian, Bob, thank you very much.
Thank you.
Yeah, thank you very much.
Thank you, Elizabeth. Thank you very much.
That was fun.
Thank you
So
all.
we stay. I'm confused. We stay.
No, no.
We say goodbye to each other, or
We can say goodbye to each other.
Hey,
Basically, the participants are still in the room. The recording will have stopped soon,
yeah,
I guess.
yeah.
Yeah, I don't know if we are allowed to stay on and continue discussing as people find it interesting, or whether we have to close.
You may. We're still there. I mean, maybe we stop the recording. I just don't dare to hit the button. Maybe Mega, if you want to hit the button. Okay. Yeah, it's up to you. So we don't want to keep you. Yeah.
No,
But
this for me, I think it's broader than just the definition, and some things that we basically touched upon. Obviously, like Bob has thought more about that than the three of us. I would be very curious, like to continue this discussion, because I'm I'll give you another biodiversity crisis. It's huge in ecology, biodiversity crisis. What does that mean? Global biodiversity crisis, similar issue. And then the studies, say the word is biodiversity is declining, and the studies show that, oh no, it's not necessarily the case. It's like you have contradicting trends. How do you communicate that? What do you do? Because biodiversity is in crisis, but not necessarily everything is, reaching a tipping point. The climate is in crisis. You see what I mean? So how do you communicate without
So I think my big advice is that you need science and technology scholars in this discussion, and the error we have been making is trying to solve this as natural scientists without people who are without social scientists who study science and its communication involved in it.
Probably you're right with that, yeah.
Yeah,
So I talk to those people, so I have some ideas, but I'm a sea level and climate scientist myself, right? So I'm not the expert on this either, but I think the error is, well, you know, we wouldn't want social scientists going on intuitive ecology or intuitive climate science, but we've let climate scientists go with intuitive social science in these spaces for too long.
I guess the risk is always that you sort of announce a tipping point, right? And then people see nothing happened, and then you completely lose the possibility of people reacting to it for something so existential like climate change.
Well, and I think that the risk is more like people aren't going to listen to us. What they're going to listen to is all the headlines blaring, we passed the 1.5 degree tipping point, right? That's going to break through. And then there's nothing. Right. Right.
There's nothing. It's a little bit unfair to say there's nothing. I mean,
well, no, I mean, we're going to pass.
Of course, none of us believes that the Earth is one system is all going to crash at the same moment in time everywhere, right? I mean,
but there is no reason in the science to believe that there is something special about 1.45 versus 1.55 degrees C versus 1.35 versus 1.45 degrees C, but people think there is.
Yeah, okay, you're right. But then I can also argue that on the other hand, which I'm not sure, but because you're the climate scientist, that you're also responding to there is a need. They ask you for a number, right? The policymakers ask you for a number.
Policymakers ask you for a number, right? Fine.
Right.
It's a
So
policy
and
target.
if you don't give them, then they also think that
I'm
you are
fine
or
with
we
it.
are
We can
unreliable.
give them targets if we're
No?
clear they're policy targets, right? 1.5 degrees is an indicator that, it's an indicator that 2.0 degrees was too high because we're already experiencing dangerous risks from climate change, and they're just going to continue to get worse at an accelerating rate the more we turn up the thermostat. Like, that's fine, but you don't need to say, and we expect something special to happen across this threshold. And I don't think most climate scientists have. Sometimes we play into it a little bit, but it's been like the people who are pushing the use of tipping points in communication are not generally being clear about the distinction between tipping points and policy thresholds. And that's the problem, because most people sort of have a vague sense of tipping point, but they know the phrase 1.5 degree tipping point, and they know that they also it sort of goes in a bundle with we have until 2030 to do something drastic to save the world.
Yeah, I think what comes in here also is the huge uncertainties, right? So when people see a scale where at specific temperature thresholds, there are specific tipping points or potential tipping points that looks like a point again. But I mean, even if the phenomenon, whatever they make of it, exists, it's a very broad, fuzzy range, right? And that is also a danger in communication to hide uncertainties that leads to this undermining of trust. Yeah. I would have one comment, Bob. You said that because of aleatoric uncertainty, we can't define a point. I wondered if that isn't a bit picky, because you could argue that maybe the exact position of the point depends on the initial condition, but still it could be a point. So if you have an ensemble, it's not a point.
So the question is two things. One, in retrospect, I think you can identify things as tipping points, right? So there's one thing. And then the other is, I think the AMOC example shows that it's not definable in terms of external forcing, right? And so I think it could say, well, there may, maybe there is a tipping point in the internal dynamics of AMOC. Like, I don't think the Model E experiments disproves that, but it does show clearly that it doesn't make sense to define the tipping point in terms of external forcing.
And conceptually, why not? If if we knew the exact state of the ocean and we had the perfect model and we run it, then we get 1 point. So I don't see why.
But that, I mean, like but that's obviously impossible. Like that's obviously impossible. Like, right? I mean, right? So like I mean, that's just saying, oh, if the world were completely deterministic, we could identify the tipping. Like what? Like right? Like it's like okay, so it just seems like it's not a point in any meaningful sense, right? There is a zone of increased risk of tipping, if you want to use the term tipping, right? I mean, the risk of tipping AMOC increases with warming. And one might even say it increases with warming more in a certain range of temperature than in another range, because by the time you get to the top end of the range, it's just going to happen. But in no practical sense, like, could you ever say prospectively that 1.6 degrees C is the tipping point for AMOC, right? You might see, oh, we get to 2 degrees C, AMOC tipped, okay, it was 1.6 degrees C, but we could have rerun history and it would have ended up with a different point.
Yeah, I see that it's a practical problem, or it's a practical fuzziness, but conceptually, I don't see that this is a counter argument against.
I mean, I guess our approach is like yeah. I mean, I think you could argue it conceptually, but I mean, my main point is we should think about the practical use of our framing devices.
But Bob, can I also ask you something, sort of, because you said that tipping points should be informed by social scientists and not physical scientists' intuition.
The use of I would say if we're going to choose a term because of its communicative effects, and I think the evidence is clear that at least initially that was why this term was chosen, we ought to have social scientists and science study scholars involved in helping figure out if we've chosen the right term. Because
okay, so it's not particular to the term tipping point.
Right. It's very specifically the framing that I'm saying we need the social scientists on. It's not necessarily okay if like the internal tech, if we never talk to anybody outside the scientific community and the term did not leak out, right, then who cares about its communicative effect? But this was chosen specifically to leak out. And so therefore, I think, like, well, one ought to add, even if one accepts if one accepts the premise that it's okay, that's an okay thing to do intellectually, then one should at least want to know scientifically whether it's a good choice. Right. I mean, it's just like, think of if it is like a political campaign, right? Would you put out your messages without doing any research to figure out whether you've gotten good messages?
Okay, got it. There is a couple of questions in the Q&A still of people who are still in the audience.
I'm gonna have to shift to my phone, but I can continue to chat.
If you want to respond to them, I don't know if you can see the Q&A. So Joshua Robles asks, question for all, could we talk about tipping points in economics when we already know that the system within which we live, meaning capitalism/consumerism, is not coping with nature, and we have to link it in another way to do economics in order to achieve the fiscal or physical thresholds or planetary boundaries? Sorry, I guess he's saying, how can we change economics in order to address the biophysical tipping points that we are achieving, or how do we need to change our economic system? Question to all.
That's a good question. I'm not an economist, so I'm careful to comment, but I sometimes have the impression that we think in a very black and white way, or like there's a dichotomy that we have different systems labeled in the past, like capitalism or whatever other thing. But there is a continuum between, or at least possibly there could be a continuum in between, right? So the system change doesn't have to be catastrophic. I guess often it was very harmful in history of mankind when when abrupt changes happen to systems. So of course in climate mitigation we don't have much time.
Well,
But
to that,
my
Alessandra,
feeling is
conversing.
my feeling is
Sorry.
it doesn't have to be a tipping point to change the system, but it will have nonlinear consequences.
To that, Alessandra Conversi says, the catastrophic tipping that will likely happen first when we reach 1.5 degrees will most likely be social. We will get to see. And last
hope.
question, and then I'll let you respond to what you want to respond or leave, is David Heward, who is still in the audience. In theory, the net present value for mitigation or adaptation actions should shoot through the roof if they somehow manage to avoid crossing tipping points. I wonder if that's a useful lens to look at the issue. Any final comments? And then we should go.
I mean, we wrote about this in our 2016 paper, not the capitalism socialism question where I agree with Vasily, but the social tipping points question. One, I mean, I think there are concerns with the social tipping point framing, but I do think in terms of abrupt changes, positive or negative, the effects on socioeconomic systems of being increasingly frequently shocked by extreme events is much more likely to be germane within current and coming decades than a mock collapse or West Antarctic ice sheet collapse. So I agree with that point that the response that the social system is probably more important in the next few decades than the physical system in terms of the potential for abrupt and rapid changes.
Thank you, Bob. Vasily, any final thoughts?
Well, I don't know what net present value is, so I won't comment on that. But I think I will just say again what I was thinking, that I think we have an issue definitely with how we apply and how we use, these terms. But I think overall we have made quite a huge progress in understanding and, at least putting some, if I won't say it, really have a proper definition to have, a quite well defined boundaries of what we think, with the term tipping points. And as with all, I guess, theories, especially the theories that are a little bit out of the mainstream, or they have an element of surprise and high uncertainty. Probably there is, this trade-off that they create sometimes, confusion and doubt. How exactly we go from that, within the science, I think it's more, at least I'm more naive to say, okay, we keep on working. I think we're refining them and we're correcting our mistakes. And I hope this is going to be, what is going to happen later. We don't stick to these ideas of, there is tipping point there, although, maybe we prove that there is not. But in terms of the interface and the communication part, I'm intrigued myself to understand better whether, using this term necessarily does involuntarily does harm to the science. I had completely the opposite idea, that if I would say to someone, look, the world can be way more uncertain and way more discontinuous than you think, from your linear, high predictable perspective, which the pandemic, small events have shown, pandemic, financial crisis. I thought that would be more, it would be more convincing rather the opposite.
With all your work on predicting tipping points, though, would you agree that we can always only know with certainty whether and where the tipping point was in retrospect after the tipping point has been crossed?
Absolutely. We're not, what we're doing, we're not predicting. We're trying to reduce that uncertainty, let's say, in terms of whether a tipping point is present, right? Not if it will happen, not when it will happen. I think that's the most we can do, and to this we are still learning from our mistakes that we started, very optimistically, but I would say also for myself at least, that you know, it's way harder than we think.
All right, Sebastian, final word.
I think that was a great final word. I agree with Vasilis. Yeah.
Great. Well, thank you very much, and thank you for staying on. Thank you for the participants still online, and hope to continue the chat in some other form.